Okay, we have successfully done two types of two-step equations. The first one was fairly basic. The second one, they threw in coefficients that were fractions. So we had to either divide by a fraction or use the reciprocal, or what we call the multiplicative inverse. This one, now we're getting into an area where there's a lot of common mistakes. And you can even see the notation in the margin of your book. It talks about a common error that's made. And usually the error is made when dealing with negative numbers. So we're going to try and give you a strategy to help deal with that. Now, the overall goal is still the same. We are trying to undo each operation in reverse order. So let's take a look at example 3 on page 123. We've got 6 minus 3x equals 21. Now, here is where all the problem is caused. This negative sign right here. What do we do with it? Because once I get rid of the 6, I've got this kind of negative sign kind of floating around. Is it a minus sign? Is it a negative 3? What is it? Devin, you have a question? Very good. So Devin says we can change a negative sign and make it plus a negative instead of subtraction. Is that something you were taught to do last year? All right. So if that helps you, here's what we're going to do. Before we do anything, we're going to rewrite this. All right? And I'm going to say 6 plus, and then I'm going to call this a negative 3x and put parentheses. You don't have to put parentheses around. If you can keep track of it, that's fine. Equals 21. Okay? Now it makes what I've got to do a lot more clear. I've got to get rid of the 6 on both sides, correct? And it's a positive 6. If you have $6 in your wallet and I want you to have no dollars in your wallet, I've got to take away or subtract $6. So I'm going to subtract 6 on both sides. And that leaves me now with that negative 3x, which equals what? 15. Okay? Now, what happens if you don't rewrite the equation is a lot of times that negative sign gets kind of lost. And we end up with 3x equals 15, which we solve and get an answer which is then incorrect. But now that we've kept that negative sign, we know to divide each side by negative 3. And x now equals negative 5. And it's very important that we keep that negative. Okay? All right? Any questions on this one? All right, let's do one more example, and then I'll let you start on those got-its. Right here, we've got a similar situation. We've got 8 minus 3x equals 14. Can someone tell me how we could rewrite that? How can we rewrite that? Emily, what do you think?
8 plus negative 3x.
Very good. So we can rewrite this as 8 plus a negative 3x equals 14. Then I can subtract 8 from both sides. All right, and I'm left with negative 3x on this side because those 8s will cancel. 14 minus 8 equals what? 6, is that correct? And then, once again, divide by that negative 3, divide by that negative 3, and x equals negative 2. And we have kept all of our negative symbols organized and kept them together. A lot of people end up doing this problem, and by the end they have maybe a positive 2 or something like that. Which, how can we tell if that's correct? Well, we can put this back into the equation, remember? If I put a positive 2 back in this equation, I get 8 minus 6, which does not equal 14. Okay? But if I put a negative 2, I get 8 minus negative 6, which is like 8 plus 6, which does work. Okay? Now I would like you to try the got-its on the bottom of page 123. Got-its E, F, and G. Got-its E, F, and G.